All right, good morning, Precalc students. I am going to make this video about how to do the problems on this study guide. I'm going to kind of go fast so I can get this video made, but you can always pause and rewind as needed. All right, so the first section here, we're going to be looking at inverse functions. So it says here, let f of x equal x plus 5 over 4. H of x is going to be the inverse of the f function. So when we're asked to find f of 3, that's just like what we would normally do. We just plug in 3 for our input. We get 8 over 4, which equals 2. But if they ask us to find h of 2, there's two ways you can do this. You can either first find your h of x function and then plug in 2 to that, or we can realize that the function just reverses the input and output. So since h is the inverse, that means we need an output of 2. So we can just take our original function f of x and set it equal to 2. And so that's what I'm going to do here. Whoops, it's x plus 5 over 4. All right, so then we're going to solve that for x. So I'm going to multiply both sides by 4. I get 8 equals x plus 5, which means that x has to be 3. So the answer to this is 3. On the next one, f of x is cube root of x plus 5. H of x is the inverse of f of x. So when I'm asked to find h of 32, again, 32 is going to be an output. So I'm going to set this equation equal to 32. Solving that for x, I subtract 5 on both sides, and I get 27 equals the cube root of x. To undo the cube root, I'm going to cube both sides, and I get x equals 19,683. Now don't worry, on your test you will not have something where you have to calculate such a big number, because you won't be able to use a calculator. All right, next one, same idea. We're given a function. They ask you to find h of 31, so again, 31 is your output. So that means we have 31 equals x to the 5th minus 1. Add 1 to both sides, and we get 32 equals x to the 5th. We take the cube root, or not cube root, but the 5th root of each side. 5th root of 32 is just 2. So the answer to this problem is 2. All right, on the next question, we're given a graph and a table. The graph is F and the table is K, and we got to find some compositions. So H circle K of negative 3. Well, K of negative 3, I go to my K table, and I see when the input is negative 3, my output is 2. So then I find H of 2. H of 2, I'm going to use my graph, and H of 2 is equal to 0. Okay? All right, then we go to the next problem. On the next problem, we're asked to find k of h of 1, so I find h of 1. H of 1, I use the graph. When x is 1, my output is 2. So then I find k of negative 2. Well, if you look at your inputs on the k function, there is no input of negative 2, so this is undefined. Okay. Next one, k of 2. Let me erase what I've drawn. K of 2. I can see that on my table. That has a value of 0. So then I find k of 0, which has an output of 1. All right, then the fourth one here, we're asked to do multiple compositions. So I start with k of negative 4. Use my k table. Negative 4 gives us an output of 3. So then we find h of 3. H of 3, I go to my graph. When x is 3, my output is 2. So this part is 2. So then we find h of 2. H of 2, according to our graph, has an output of 0. On the next one, f of x is the table and g of x is this equation, and they want us to find f of g of 0. Okay, so first we need to figure out g of 0. So g of 0 means I take my equation, this right here, and I plug in 0 for the x's. the 0 is 1. 0 squared is 0, so that gives me 1. Okay, so that means my output for that is 1. So now I find f of 1. F of 1, I use my table, and I get -3. On this next one, if something is exponential, that means you have equal length inputs, and you have proportional outputs. If it's logarithmic, so logarithmic is just going to be the reverse of that. So if you have logarithmic, you have proportional inputs, and you have equal length outputs. Okay? So based on knowing those things, let's see what tables we have here. So on g of x, I can see that my inputs are multiplying by 2 each time. So we have proportional inputs, and my outputs are equal length. So that means this is logarithmic. On the second one, I have, it looks like we're multiplying the inputs by 5 each time. So we have proportional inputs, and we have equal length outputs. So this is also logarithmic. On k of x, I have equal length inputs, and my outputs, it looks like I am multiplying by 1/2 each time, so this is exponential. Okay. All right, the next problem asks us to refer back to this function k of x. So we're going to go back to this table here, and we're going to answer if each of these questions are true or false. First one says k inverse of 0.0625 equals 5. Well, that means that this would be the output of k, and the 5 would be the input of k. So when I look at this, when my output of k was 0.0625, my input was 5. So this is true. Okay. Next one, k of x is exponential with a base of 1/2. We did that a moment ago. We do see it's exponential, and your outputs, you are multiplying by 1/2 each time. So this is also true. C says as the output values of k inverse halves, the input is increased by 1. Okay, so remember we're talking about the inverse here. So let me erase some of this. Talking about the inverse. So when we think about the inverse, if I make a table for the inverse, I'm switching my inputs and outputs. Okay, so there's my k inverse. So now it says as the outputs of k inverse halves, well, the outputs of k inverse are not halving. This is false. Okay? D says as the output values of k halves. So here we're looking at the original table for k. And in this case, that is true, and the inputs are increasing by 1, so this is true. Next one says the graph of f has a property such that each time the input values multiply by 3, so that means proportional inputs, the outputs increase by 1, so that's equal length outputs. So that means that the graph is a log graph. Okay, so if I wanted to make a table of values for this, so it says as our outputs increase by 1, so 0, 1, and 2, my input should multiply by 3. Okay, so I'd have 1, 3, 9. So I'm going to plot 1, 0, 3, 1, and 9, 2. And it should graph something like this. Okay, what you need to know is this is a logarithmic graph, and logarithmic graphs always look like this. So we have a vertical asymptote at x equals 0, all right? Meaning that there's this boundary line that's not going to cross. And then it should just curve off and go up forever, okay? This will be in the context of a multiple choice on your test, so you would just look for the graph that looks like what I just drew here. All right, question 9, we're given a a graph for g of x, and on this graph, we need to answer some questions. They tell us that k is going to be the inverse of g, all right? So what I like to do first is I like to think about the domain and the range of our our g function. The domain of g goes from -4 to +3. And the range goes from -3 to 7. Okay? Now what we're going to do is we're going to think about the inverse. The inverse function, remember, switches your domain and range. Okay, so what I had here was, this was g. Now I'm going to figure out k, which is equal to the inverse of g. So that means that my domain and range will flip-flop. So my domain for g inverse, which is k, is going to be -3 to 7, and my range is going to be -4 to 3. Okay? All right, so now to answer some questions. So k of 3, remember that's the same as finding g inverse of 3. So 3 is your output. So we look for an output of 3, and we want to see what its input was on the g function. So that would have been 0. Maximum value for k of x, well, we look at the range of k, which is g inverse, and we look for the highest value. All right, so the highest value in the range of our inverse is 3. For the minimum, we're looking at the range of k, and we look for the lowest value. All right, so when I'm doing that, that would be -4. And then the range for k of x, well, I've already answered that, so we'll just write it down. All right. Now we get into some logarithms, so we're asked to evaluate some logarithms. So on the first one, I see log 100. There is not a base number written, so remember that is a base of 10. So ask yourself, 10 to what power equals 100? Well, that would be 2. Next one, 8 to the 1/3 is the same as the cube root of 8, which would be 2. So A is 2. Next one, remember natural log is the same as log base e of, and that e, think of that as e to the first power. Log base e cancels with e, so this value is just 1. Remember, if the base and the argument are the same, then the logarithm always equals 1. All right, then the fourth one here, 100 to the 1/2 will equal a. Well, the 100 to the 1/2 is the square root of 100, so that's going to be 10. So a is 10. All right, question 11, find the inverse. So remember, f of x just means y equals. So the first thing we have to do is switch the x and y around. So anywhere that there was an x, you put a y, and anywhere that was a y, you put an x. And I like to make this look like a fraction so that I can then cross multiply. Okay, so when I cross multiply, 1 times 2 minus 3y is just 2 minus 3y. And then we cross multiply the other way. We take this x and we distribute it to the 5 minus 2x. Or that should have been a 2y, I'm so sorry. Sorry, that was a y. All right, so then when I distribute this, remember you're distributing it, so it'll be 5x minus 2xy. All right, we need to get our y's to the same side, so we're going to add 2xy to both sides. I'm I'm also going to subtract this 2 on both sides. And so here we get negative 3y plus 2xy equals 5x minus 2. Well, I see a common factor of y, so let's factor it out. And I'm going to rewrite this as 2x minus 3. So then final step, divide by 2x minus 3 on both sides. And now we have our inverse function. All right. Last thing is the free response. So listen closely as I go through these, all right? So we're given a graph for h of x, and then we're also given an equation for g of x. So please pay careful attention to which function you're supposed to be referencing when you do these problems. First question says the function j is defined as a composition of g of h of x. And they want us to find the value of j of negative 1. All right, I'm going to show this work up above here. So j of negative 1 is just the same as g of h of negative 1. H of negative 1, we use the graph. When our input is negative 1, our output is 1. So then we use that 1 as our input for g. So g of 1 would be 2 plus natural log of 1. Well, natural log of 1, remember that's saying e to what power equals 1? Well, anything to the 0 power equals 1. So the natural log of 1 is 0. So to answer part 1, you should get 2. For part B, it says find all values of x for which h of x equals 3. So that means we're looking at our graph of h, and we need to look for the output of 3. So I can see that there are 2 locations that have an output of 3. So we just identify those x values. So those x values are negative 5 and positive 3. All right. Now for part B. Item 1 says, what is g of e cubed? So notice it's the g function, so use your g of x equation. So it'll be 2 plus natural log of e cubed. Remember, natural log of e cubed is the same as saying e to what power equals e cubed. So that power must have been 3. So 2 plus 3 is 5. For part 2, I'm going to do part 2 down below here. It says determine the end behavior of g as x increases without bound. Well, g is just a natural log graph shifted up 2 units. So it's going to have a look something similar to this, but shifted up 2 units. So it says, what is the end behavior as x increases without bound? So that means limit as x goes to infinity, because if you're increasing without bound, your x goes on forever. We must give it a function named g of x. And as you can see from our graph, as our inputs go on forever to infinity, the outputs are just going to keep on rising. So that limit is infinity. All right, part C, last part. Determine if if h is invertible. Well, it is not. And the reason for that is because, so that's part 2, when x equals negative 5 and x equals 3, we have the same output. So h, when inverted, would not be a function. All right, my friends, happy studying, and reach out with any questions that you may have.